Point. So first of all, we'll discuss about what is point. So in general, let's take an example over here. So this one is let's say we have this one, this point. So we'll say this is a point A. So the definition of a point is a mark. So this is a mark. So mark of position, mark of position represented in form of dot, represented in form of dot. So like this is point B, here I have C, this is D, so this is E. So the dot point that we represent, this is known as a point. The smallest dot near to the line, that is a dot. So for example, if I just put this one, so this is a dot, this is a dot, this is a dot. So these are A dash, B dash, C dash, D dash. All these are the point. So we will say that we will have n number of points in a plane. So whatever this that I have represented, this is x dash, y dash, z dash, or w dash. So this, in this plane we have n number of points that are actually geometrical representation of point. So now the point to be noted over here. So the noting point is, a point has no length, no width, and no thickness. So what we said, a point has no length, no width, there is no width or breadth, and finally is no thickness. Okay, so these are the point that you should have to know. And one more thing, whenever we represent a point, so for example, let's take an example. This is the here I am just representing. Always we represent a capital letter A. If this is a point, this is represented by capital letter B. Okay, so after completion of the point, let's move to the another thing, that is line segment. What is line segment? That is line segment. So what is line segment? So line segment is, if we have 2 points, let's first understand this is let's consider we have 2 points. So like this is the point A, and this is the last point of here I am denoted, this is point B. So the line segment between 2 points A and B is known as a line segment. So this is known as this AB, this A and B, we are representing this is as a line segment. So a straight path, or a straight, we can say a straight path between 2 points, let's A is a 1 point, this is 1 point, and this is the another point. A and B is the line segment. Is the line segment. And how we will represent the line segment? AB, and after that we will put the bar over here. So that, so the A and B will have some fixed distance. Okay, so it will have definite length. So what are the points about the line segment? So the first point about the line segment is it's a defined length or definite length. Okay, so one more thing, like, got it now? We have a definite length of a line segment. So let's move to the another topic, that is ray. What is ray? So ray, a line segment which can be extended in one direction till infinity. So like let's take an example. We have a this is the here we have a bulb. Okay, this is a bulb and it emits a light. So that light is emitting it to the this one side is fixed and the another side is still infinity. So this is one ray. So ray is a point like from a bulb. We are sent, when we switched on the bulb from a one point, the rays are emitted from one direction and it will go to the infinity to another direction. So this point, let's consider this is a point A, until infinity. Except so the point is the ray has no definite length. Ray has no endpoint. A ray has one endpoint, one endpoint, that we'll say A. So ray has one endpoint and no definite length. And finally, no definite length. So the point that we want to say, one endpoint and no definite length, okay, that's known as the ray. So come to the another definition of line. Now we will reach at the line. What exactly the line is? So a line segment AB that can be extended infinitely in both the directions. So let's say we have a point A and another point we will say B, and now let's we will combine these 2 points. When it will be set as a line, so it can be extended infinity to towards this direction and it can be extended infinity towards this direction. So that's known as a line. So now we come to the definition of a line segment. A line segment, a line segment. This is the line segment. AB is the line segment. So the line segment AB, when extends, when extend, when extended, infinite, infinitely in both direction, in both direction, is called line, and that line is AB here in the blue example. So let's discuss about the points of a line. The first point that we are going to discuss, the point number one, a line has no endpoint. First thing is, a line has no endpoint. Second, a line has no definite length. A line has no definite length. Point number third, a line can't be drawn. It can simply be presented in one plane. Okay, so that's we'll not consider this point. I think we can draw the line and it can be presented on the plane as well. Okay, so now we'll come to the another topic or another content that we can say. Let's move to the another part. Another part is collinear point. What is collinear point? Collinear. What is collinear point? So let's consider we have 3 points. Collinear point is if three or more points on the same plane on a line on the same line, that is known as the collinear point. So for example, if I have this one and if I join all of them like this, so this point A, this point B, this point C, and this point D. All these points are lying in the same plane and on the same line. So that is known as the collinear points. Where if I take here X and Y, X and Y are known collinear points. Okay, we can draw the line segment, but these are not on the this AB. If I say this is a line L, and in this line L, A, B, C, this all these points are lying on this line L. So these are not known as the collinear point, but X and Y, this X and Y are not the collinear points. Understood? Okay. So another topic is non-collinear that we already discussed. Non-collinear, non-collinear point. So what exactly the non-collinear point? So like one point is here, one point is here, one point is here, one point is here, one point is here. If I draw one line, we can join the two lines. Another line we can join. Another we can do. Another we can join. Another we can join. So let's take this is A, B, C, D, E. So these lines we can draw. This is line L1. This is line L2. This is line L3. This is line L4. This is line L5. So they have their own lines. So this is known as the collinear points. Actually, this is known as the non-collinear point. So let's recap what we discussed. So first we discuss about what is a point. Then we discuss about the point has no length, no width, and no breadth and no thickness. Line segment have a fixed definite length. It will be like A and B will be definite length. Ray from one point it's fixed and another point it have no definite length. Line is A and B, but we can extend it to the infinity. Okay. So then we after that we discuss about collinear point and collinear and non-collinear point. Okay. So now we are going to discuss about how many lines we can draw from a point. So like number of lines that we can draw through non-collinear point. So now the point that we are going to discuss is very specific. So how many we have to find how many number of lines that can we draw can be drawn through and non-collinear. This is non-collinear points. So let's take an example. We have this value n is equal to 5. So we have 5 non-collinear points. So we have to find how many lines we can draw from this 5 non-collinear points. So let's take 5 non-collinear points. 1, 2, 3, 4, and this one is 5. So one way will come. Okay, we can line this A and B. Another we can C and D. This BC. Another will say it's E. Then we will say F. Okay, so this is 1, 2, 3, 4. 4 lines we can draw, but we cannot find like this. How we can find? Let's have a formula. So the formula for this one is n minus 1 divided by 2. So let's take n value is 5 here. Now 5 minus 1 divided by 4 divided by 2. So here we have 5 multiplied by 4 divided by 2. So this is 2. So how many number of lines we can draw with this 5.10 lines? So how we can do 1, 2, 3, 4, 1, 2, 3, 4 lines we have here. Another is 5, 6, 7, then 8, then 9. Okay. So let's take now we'll count this one. How many number of lines we have here? This is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then we have here 9. This is ninth line. Anyone we missed? total number of lines that we can draw is 10. Let me check any line that we missed. Okay, that line we missed 10. So total number of lines that we get drawn from this one. So if anybody will give you like n is equal to 15, so it's not possible to identify with the help of this point to join like this one. It's very difficult to identify how many number of collinear point you can do. So the better way, you can use this formula n is equal to n minus 1 divided by 2. How many number of lines in the collinear plane? So this formula will help you. So you can solve one question. I will give you one question. Tell me number of lines drawn. Number of line can be drawn. You will write the question. Number of line can be drawn from a point. Uh, if we have 75 points, then how many number of lines we can draw in a collinear points? These collinear points. We have the number n is equal to here. What we said. N is equal to, okay, the value of n is equal to here 75. So you have to tell how many number of lines we can draw. Find number of line we can draw in non-collinear non-collinear points. All these 75 points are in a non-collinear, so you have to find how many number of lines we can draw. So the formula for this one is n minus 1 divided by 2. So what we did, we'll substitute the value here, 75 minus 1 divided by 2. So let's solve this one. 75 multiplied by 74 divided by 2, 2 3 ja and 2 7 ja. So the simple way is you have to multiply this one. So this number of lines, whatever the result it will come. So this number of lines we can draw from this 75. 75. If we have 75 non-linear points, then we can do. Any doubt? So what is the, when we divide multiply this one? So here we will have 5. Then we will have here 7, 7, 2. So this number of lines you can draw from this 75 points. Okay, let's start with discussion with about plane. What exactly our next topic is? We'll discuss about plane. So let's discuss about plane. What is planes? Okay, so the definition, when we talk about the definition is a flat surface which can extend endless in all the direction is known as plane. So if we will take an example like this is one plane, this is one plane. If I'll take another example like this is another plane here. If I take another example, so like this is another plane. So all these are, this is plane 1, this is plane 2, this is plane 3. I'm just representing this one. So basically all these are smooth surface that can be extended infinity to their own directions. So all these are planes. In both the direction it can be extended. Okay. So let's have a point about it. A plane has an infinite length and breadth, but have no thickness. What it means? A plane has infinite length, and breadth, but has no thickness. So the point is no has length and breadth but has no thickness. Got it? What we said has no thickness. Okay. So now if we have three known collinear points, okay, so it will lie in a one plane. So let's say I will take an example of a plane. So this these are the 3 points. So this is one plane. If I have 3 points like this, so this is another plane. If I have 3 points like this, so this is another plane. If I have 4 points like this is another plane. So this is an example of a plane. So this is A and B, this is C and D and E. Here it's C. Let's consider here. So the point that I want to just tell you how we are representing this one. So these are the 3 points. One, two, three, 3 points that we are. Any three points you can take, and you can combine them. It will become a plane. Okay. So now let's have a discussion about plane figures. When an enclosed figure drawn in a plane with a flat surface is known as a plane figure. So like we can have an example here. This is a triangle. We have circle also. We have rectangle also. Okay. So all these are the plane figures. Plane figures means so we can have segments. So now we will discuss about number of line segment. Number of line segment. What we are going to discuss about number of line segment. Number of line segment means if I have a point like A point, we have B point, we have C point, D point, E point, and till we have the infinity point R on the line segment. R on line segment that we can say AB is let's consider PQ will be a line segment. Okay, then the number of line segment determined by point n. So what we have to do, we have to find that in this PQ, how many number of line segments are in this one. So here n is equal to n minus 1 divided by 2 that we discussed earlier. Now, so how many number of line segments we can do. So same way now what we discuss. Okay. Now we will discuss about conjugate line segment. Okay. So what is conjugate line segment? If the length of the two line segments are same, then they are called a conjugate line segments. Conjugate line segments we will say if this is a point A, another is this is point B. If we combine this line, same way we have C and D. In geometry, what we represent like C and D, this we will see AB. This AB will be the length of this line. Okay, another CD will be the length of this line. Okay, so if I represent this AB and this is equal to CD, and after this one I will put like this. Okay, so this is the symbol that I am just going to represent here. That is the conjugate symbol. What is the symbol? Conjugate. Sorry, concurrent, not conjugate. Concurrent line segment. That is concurrent line segment, not conjugate. Concurrent line segment. So these two lines are concurrent. But I say AB is concurrent to CD. Okay. So now we will come into the how we units and the symbols. So what will be the unit of a line? So I am just writing here unit and its symbol. Okay, and the relationship. Okay, first we'll understand the unit. So we will write millimeter. So millimeter we will represent by mm. Then we will have centimeter. So centimeter it is represented by cm. decimeter. Decimeter is represented by dm. Then we will have decameter. Decameter. Decameter we will represent it by dm. Then we will have hectameter. Hectameter we will represent it by hm. Then we will have kilometer. Kilometer we will represent it by kilometers, like this. So now we will represent the relationship of millimeter. So 1 millimeter is equal to 1 upon 1000. This is millimeters. This is mts. Okay. So 1 centimeter is equal to 1 upon 100. 1 decameter is equal to 1 upon 10 mts. 1 decimeter is equal to 1 upon is equal to 10 mts. 1 hectameter is equal to 100 mts. 1 kilometer is equal to 1000 mts. Okay, so the point that is here, you should have this table in your mind. And one more thing, how we will represent this thing. So, like if I have this point, if a person travel from point this A to B, and when he reached at point C, the distance of this one is like 100 meter. Then he will reach to the point E. This point, the distance is 1 kilometer. If another point that he will do, he has travels 5 kilometers. So the total distance of this one is 1 kilometer plus 5 kilometer plus 100 meter. So the total distance is 6 kilometer and 100 meter. So if you want to represent this in 6 point, okay, 6.1 kilometer. Okay, understood. So now we will come into the let's have a discussion. We have a point. Let's take a point. This is a point A. This is point B, and this is point C. Okay. So this point A is equal to this point B. So what we say, AB is equal to BC. So what we have to do, if anybody will say the value of this AB point is equal to 5 centimeter, and find value of AC. So how you will find how this AC point will be created? AC point is equal to AB plus BC. This is equal to from this to this and this to this. So what is this value? AB is equal to AC. So we can write this is equal to AB plus AB, because both the points are the same points. So we will say it's a 2 of AB, and we know the value of AB. AB is equal to 5 centimeter. So this AC is equal to 10 centimeter. So the total value of this length of this AC is equal to 10 centimeter. Clear? Okay. Let's repeat it again. We will have 2 points. This is point A and this is point B and this point C. Okay. The distance between this point, the distance between this point A and B, this point, the distance between this point is we have given here 5 centimeter. Okay. Now another condition that we have given is this one. This point AB is equal to this one BC, from here to here. Both the points are equal. So this AC, how this AC is created? AC is equal to AB plus BC. Clear? This AB plus BC, then we will get the AC. So this BC is equal to AB. We can put the value of AB over here. Both are equal. When we add this one, so this will become to the 2AB. Clear? Now, what is the length of this AB? AB length is 5 centimeter. Here we have 5 centimeter. So we put the value of this AB here, 5 centimeter. When we multiply, so the final result is 10 centimeter. So the length of this AC is 10 centimeter. Clear? So now we'll move to the another point. Let's have discuss another point. Parallel line and intersection line. Okay. So let's have a parallel line. What is a parallel line and what is intersection line? I have a line that is, this is one line, and I have another line, this one. Okay. So let's take this as a parallel line. So we'll take another line. So when we set a line, this we have a line A, B, another line we have C and D. When we said this AB is parallel to this CD, what are the conditions? So the condition is a line is said to be parallel. For example, this point, at any point, at any point, that this distance, that this is the distance, this distance D, D, D. If the distance is equal at any point of time on between these two lines, so these lines are said to be the parallel lines. Clear? What is the definition of a parallel line? The two lines are said to be parallel when the distance between the 2 points, the distance between these two lines, sorry, at any point, okay, is always equal. Then it will be the parallel line. So what we discuss here, parallel line, parallel line. Then what is intersection line? Intersection line. Intersection line means I have a line AB and this is BC and it is intersecting at some common point, like P will be the point where it is intersecting. So this is known as the intersection line. Okay, clear? Now we will discuss about some properties of a plane. So we have inclinance property of plane. The first property is, so if anybody will say some planes are coplanar points. So coplanar point means this is a plane and these lies in this one. So this is A, B, C, D, E and F. All these are in the same coplanar plane. Okay. So same way, a line segment belonging to the same plane is called as a coplanar line. So let's take, we have this one. This is a line segment. Okay, this is line segment L1. This is another line segment L2. This is line segment L3. All these lines are belonging to the same coplanar, same coplane. Okay, line L1, L2, L3 are the same coplanar. Okay, the point 3 will be only one line can be drawn through a point, and the line is in a coplanar between A and B, and it can be extended to infinity. Okay, in a curve. So now we'll discuss about a few of the questions. So let's take the questions first.
Okay, so we're going to start. Okay, let's start with the discussion of geometrical formulas. Bring the marker. here. Can sit over here. It's 19%. Charger also. Okay. So today we are going to start about mensuration. So our topic for the today's we will solve the exercise of the mensuration. So before moving into the questions of mensuration, we will be solving the. So today we will solve this exercise for mensuration. So let's understand what is the rectilinear figure. So first of all, what is rectilinear figure? Rectilinear figure. Yeah, tell me what do you understand by rectilinear figure? So rectilinear figure, a closed figure formed by straight line segments is known as. So for example, this is a figure that I created with the help of straight lines. So that is known as the rectilinear figure. So now we'll understand what are the rectilinear figure. So this is the, let's take this as we will have this square also. This another we will take an example of rectangle. We can take an example of triangle. So we can have the parallelogram. Okay, we will have rhombus over here. So all these are example of the rectilinear figures. Okay, or we can say in simple words a polygon. So we can simply say that a polygon is is an example of a rectilinear figure. So now we understood about rectilinear figure. So another term we'll understand a region. What exactly the reason is. So in simple words, if we'll say a region is a plane. So in the previous session we discussed about plane. So a part of the plane which is enclosed by some line segment or a closed figure is known as if. So let's take, so this is one reason. So we can say whatever we are going to marked. So this one is the one region. So this is an enclosed one. So this is one region. Another reason is this is another reason. So in our questions, basically we have communicated that you have to find the area of this particular region. So let's take an example. So I have one. So let's we will draw this. So what we need to do. So if anybody will say, we have to find this area of this particular region. So that is shaded over here. So we have to find the area of this particular region, and what we have given. So the length of this one is given like we have 10 meter. and the breadth of this outer one is 5 meter, and the inner one will be 3 meter, and here it is 2 meter. So it's 2 meter. So whatever the colored region, we have to find the area of this colored region. Area of colored region. So what we have to do before understanding and solving the questions, we should know what exactly the reason is. So the reason is a part of a plane which is enclosed by some line segments. So this is the line segment over here. So here it's not like this. So what we're trying to do? So this we are going to compute the area of this particular run. So one more thing I noticed whenever the students will solving the questions, so we should have we should have the units also. Okay, units means, so let's take an example over here. So this is a rectangle. Okay, in this rectangle, let me just tell this is 10 meter. Okay, so this I am just denoting this is meter, and this is very important unit when you are writing your questions now. So you should have to specify. Without this, if I am just writing here 10, what is this 10? It's not it's just denoted the magnitude. It's not denoted its length. So whenever you have write, so it should also you should also write its unit also. So this is the and if here I'm writing 5 meter. So if I'm writing here length, so you should have to write it's a unit also. When I'm writing here it's a breadth also, so you should also write its unit. So now I'm just writing area. So area is equal to length into breadth. Okay, so when we solve this one, so it's a 10 meter into 5 meter. So it will be 50 meters square. So what the point I'm trying to convey, the point is here, whenever you are computing anything, area you are computing, you are writing the length, its unit should be written along with it. Without its units, there is no meaning of your question. Okay. So whenever you are solving, for example, you are solving area, so you should have to so unit of whenever you are writing here area, so the unit will be in the meter square, centimeter square, or decameter square, or anything, whatever the meter, whatever the length of your dimensions, based on that it will be. So when you are computing like volume, so volume will be I have this enclosed figure. So this is the enclosed figure here. So how much volume of this enclosed, how much amount of data we can store in this enclosed figure, that is known as the volume. So whenever the volume you compute, the volume will have this length, then we have the breadth, and this height will have. So length, breadth, and the height. So we know unit of the length is meter, assume like this right now. Then we have breadth is also in meter, this is also in meter. So my unit of the volume will be in the meter cube. So always be be conscious when you are writing any of when you are computing any of the standard methods, you should have to write the units. Okay, so let's now take an example. Simply, we will just going to draw some examples, and you have to just tell me the area of the following. So we will discuss about. So like this is my figure, okay, and another figure we will have here. We will draw another figure that will be. Let's take. We have another figure. So that is another figure. So let's draw another figure. You have to find the area parameter, and so first we will discuss, then take one more, so that we will be discuss all these things in the same. Okay, so in this is the diagram over here. So we will be discussing about parameter. Okay, then we will be discussing about here area. So this is my, let's take here. This is the length, this is the breadth. Here, this is square. So this is rectangle, this is square. So all the sides will be this is SSS. Okay. And in this triangle, we will have the base is B, and we can take this is our height. Height of this triangle is H. Okay, this is the circle's center point O, and this one is the radius. R is the radius. So when we are discussing about the parameter of a square, so parameter what we discussed earlier also, we'll start running from this point, and around this rectangle we will be revolving and reaching again back to this point. So this is known as the parameter. So let's start the discussion. So we will start from this point O. Okay, we will reach to this point B, then C, and then D. So the parameter of this one will be OB plus BC plus CD plus DO. Again, at the end, we are reaching at that point. So if we will compute this value, so this is B plus this is L, the value of this one, this is B, uh, again this is L. So we can say here we have 2L plus 2B. So we can simply write it like L plus B also, 2L plus B. So this is the parameter over here. Same thing, we are just trying to compute the area. So we know area of a triangle. So area means what is the how much region inside this in this shaded region. Okay, so how we will be computing this area? So we'll write it area is equal to, and one more thing I want to address here, the unit of parameter will be in meter. Matlab, it's in whatever the, so if I say here uh, my length will be whatever my length, it will be in meter, breadth will be in meter. Okay, so my parameter will always be in meter, because I am not doing any kind of multiplication, I am just doing the addition. So now in case of the area, we have length into breadth. So whatever the length we will have here, L into B, we will multiply, we will compute this one, and the unit of this one is the square meter or square centimeter. Okay, so we will write like meter square like also. Okay, we'll write like this. So now we will move to the another part, the parameter of a square. So same way, if we will compute the parameter, we'll start running from this point, reach this point, then we'll come to this point, then we'll again come back to particular this point. So what it means, it will have the we will have the area of this square. So what would be the area of this square? The area of this square will be the uh, we will start running from the point we'll start so I just start from this point, so s plus s plus s plus s, so it is like a 4s. So the unit of this one will be in the meter. If I have this side will be in the meters, so my unit of the parameter will always be in the meters. So the next part is area of the square is equal to side into side. So whatever we compute, it will be in the meter square. Okay, so another let's come to the triangle. So the triangle, the sides will be like a b and c. These are the three sides of this triangle. So now parameter of this triangle is, will start running from this, reach at this B point, then we'll come to the C point, and then come to the A point. So the parameter is here A plus B plus C. So this is my parameter. Okay. So now area of a triangle will be uh, 1 upon 2 base into height. Clear? And area of a parameter of a circle is, so this is equal to 2 pi r. So this is the parameter of a circle. So like tomorrow, if we have to compute the parameter of a semicircle, so this is a circle O having the radius r. So the parameter of a semicircle is pi r. Okay. So now tomorrow, if I will halve this one, so this is my semi. half of this semicircle.
One fourth.
So this is one fourth. So this will be when we divide it by 2
Pi
pi
r by
r by 4, so it will be 1 upon 2 pi r. Okay, so this, now what is the unit of the parameter? Parameter unit will always be in
meter.
whatever the unit of our radius. So the radius unit will be in meter, it will be in meter, centimeter, it will be in centimeter. Same thing if I'm talking about the square. Square, the area is equal to pi r square. Okay, so the unit will be in meter square or centimeter square or whatever the unit of your radius is. So that will be the square of that one. So this is the basic formulas. Based on that, we will be solving the questions. So one more before moving to the questions, let's have understand some more points here. So what more points we will have here? So like we will have one triangle. Okay, so this is a triangle here. So in this triangle, we will have what we are trying to do. This is A, this is B, and this is C. Okay, the AB will be A. I'm writing is A meter. Okay, this is my unit. This is B meter. I'm specifying this is C meter. Okay, this M will be denoting as the unit of the side. Whatever the unit, it will be like meter, it will be centimeter, it will be anything. Okay, so it kilometer also it will be. So now the point is we don't have the height of this triangle. What we have to compute? We have to compute the area of this triangle. We want to find the area of this triangle. So how we will compute the area of this triangle? So basically, first of all, uh, before computing the area of a triangle, we need to find the parameter. Parameter, I explained you, parameter is equal to a plus b plus c. Okay, so another term is semi parameter. Semi parameter means half of this parameter. So the a plus b plus c divided by 2, that will be the result of my semi parameter. So, in case of the semi-parameter, what we have to do, we will calculate the semi-parameter over here, and we denote the semi-parameter with the symbol S. Okay. So the area is A is equal to, we will writing like this, under the root S into S minus A, S minus B, and S minus C. Okay. So now let's take a value of this one will be 5. Here we have 4, here we have 6. Okay, so now we need to compute the area of this triangle. Again, I am telling the unit of the area will be always be the square of its length, square of its dimension that is mentioned over here. So now in this one, what we are going to compute? We are going to compute S. S is equal to A plus B plus C divided by 2. So let's have here 5 plus 4 plus 6 divided by 2. So this is equal to 15 by 2. This is equal to 7.5. I am computing here. What is I'm computing? Parameter, semi parameter. So I told in the beginning, what I am not doing any kind of multiplication over here. So my unit will be here in meters only. So why I am trying to, my unit will be in always in meters. So unit will be in meters. So this unit is very very important for anyone to explain what we are doing. So now let's move to the solution for the this one, area. So we already know this is the formula of our area. So what we did, we compute the S. So now we need to compute this S minus A. So let's here compute S minus A. We'll compute S minus B, and then we'll compute S minus C. So here we have 7.5 minus value of A, we will be taking over here 5. So here 7.5 minus value of B will be we'll consider it 4. Value of c will be 7.5 minus 6. So here it is 2.5. It here, what will be the remaining over here? It is 1.5, Shri. It's 1.5, no? Is it correct or not? It's 1.5 or 2.5. That I want to check whether you are sleeping or what you are doing. So it is, why 1.5? 2.5. It's 2.5. So that will be in meter also. And when we are solving this one, this is 3.5. When we are solving this one, this is 1.5. Okay, so now what we did, we compute all the values. So now we have to substitute these values 7.5. Then we have to multiply is 2.5. Then we have to multiply 3.5. Then we have to multiply 1.5. And when we solve this one, so we will get the result of our area, and the result will be in the meter square. Correct? So the objective of this question is to introduce the formula of this area and what is semi-parameter. Okay, that I have explained you. Now we will come to the one more. If like okay, so let's solve the question. Okay, when we solve the question, then we will have more practice in this one. Okay, let's start with numerical questions now. Okay. Okay, okay. So we will